125 million years ago, at the height of the Cretaceous period, feathered dinosaurs roamed what is today North America, Europe, Asia, and Africa. They were small, flightless birds, with large, powerful jaws filled with sharp teeth, and long, bony tails that dragged along the ground behind them. They looked like a mix between a turkey and a T-Rex, except instead of being bulky and fearsome predators, they were more like oversized chickens pecking around for food. But these strange creatures weren't actually birds. And they weren't dinosaurs either. They were something in between. And their fossils tell us a story about how dinosaurs became birds, or more accurately, how some species of bird became dinosaurs. Hi, it's me and welcome to this channel. Today, we're going to talk about how dinosaurs evolved from birds. No, wait, birds evolved from dinosaurs. Well, actually, both. Let's start at the beginning. Birds and dinosaurs have been a source of endless fascination for paleontologists because understanding their evolutionary relationship can help us learn how all living birds evolved from their ancient ancestors. And the discovery of feathered dinosaurs has led to an ongoing debate over exactly where birds fit into the grand scheme of things. Like many scientific debates, there are two main schools of thought. One is known as the Saurischian or lizard-hipped camp, while the other is known as the Ornithischian or bird-hipped camp. And even though those names might sound like something out of Harry Potter, they're actually based on the shape of their hips. The Saurischia were mostly meat-eaters and had a hip structure similar to modern lizards, with a hole in their pelvis where leg bones connected. Meanwhile, the Ornithischia were mostly plant-eaters whose legs connected directly to their body without any hole, just like birds do. For a long time, scientists thought the two groups diverged early on in the history of dinosaurs and went on separate evolutionary paths. But recent discoveries have revealed that the split actually happened much later than we thought, and that the ancestors of both groups were probably feathered dinosaurs that resemble Archaeopteryx. The oldest known species of Archaeopteryx lived around 150 million years ago during the late Jurassic period. It was about the size of a golden eagle, with a wingspan of almost 2 meters. Like most other archosaurs, it had a long, pointed beak with sharp teeth, bony plates along its tail, and feathers covering its body. While it may have looked like a bird, it also shared traits with small carnivorous dinosaurs called theropods, such as a hole in its hip socket, 3 toes on each hand, and a relatively short neck. In fact, when it comes to evolution, you can think of Archaeopteryx as kind of a combo platter. It combined features from both of its parent lineages, which means it was neither a dinosaur nor a bird, but something in between. What makes Archaeopteryx so special is that it's the oldest known species of bird that we've found. And by studying its fossils, scientists have learned that birds and theropod dinosaurs branched off from a common ancestor approximately 200 million years ago. At first glance, that doesn't seem to make much sense. How could the ancestors of birds be dinosaurs? Wouldn't that mean birds aren't actually related at all? Not really. It just means that the group we call dinosaurs is a lot more complex than we once thought. And according to new research, we may have been looking at the whole thing the wrong way. Last year, scientists used advanced imaging techniques to look inside the fossilized remains of a relative of Ankylosaurus. Their goal was to determine whether it was a lizard-hipped or bird-hipped dinosaur, and what they found surprised them. Instead of belonging to one group or the other, the fossil showed features of both. That discovery suggested that the traditional categories of lizard-hipped and bird-hipped might not accurately reflect how dinosaurs evolved. So they decided to take a closer look at other fossils, including several relatives of Ankylosaurus and a 14-year-old Tyrannosaurus named Scotty. What they found was that rather than being the result of two separate evolutionary events, all dinosaurs probably inherited their bird-like hips from a common ancestor that lived between 230 and 245 million years ago during the Triassic period. In other words, all dinosaurs were technically bird-hipped. Some of them, like the theropods, eventually developed more lizard-like features through a process known as convergent evolution. This happens when species independently evolve similar traits as adaptations to similar environments, behaviors, or ecological roles. For example, birds and insects both have wings, but they're not closely related. Wings evolved independently in these two groups because they fill a similar function in the sky. Similarly, theropod dinosaurs and modern lizards both have holes in their hip sockets because having a hole allows for greater flexibility when moving on land. So the theropods ended up evolving into fast-moving carnivores, while the ornithischians gave rise to a bunch of different plant-eating dinosaurs, including the duck-billed hadrosaurs, horned ceratopsians, armored ankylosaurs, and many others. So does this new discovery change anything for birds? Actually, yes and no. From an evolutionary standpoint, all dinosaurs were birds, and all birds were dinosaurs. But from a classification standpoint, that's not really true. Scientists don't currently consider birds to be dinosaurs because they lack certain characteristics that define the group, such as a hip with a hole in it. So birds and dinosaurs are both right in that sense. And scientists haven't yet figured out how to reconcile these competing ideas. That's why the discovery of feathered dinosaurs has been so important. By piecing together the characteristics of ancient creatures like Archaeopteryx and Confuciusornis, we can better understand how birds and dinosaurs are related. Take Confuciusornis, for example. This species lived in China during the early Cretaceous and was one of the first birds to have true feathers. It was about the size of a crow and had a wingspan of around 1.4 meters. Its skull was mostly toothless except for a few small teeth at the front of its mouth, which means it probably ate fruit or insects. It also had fur-like feathers that covered its entire body, including its wings. Unlike Archaeopteryx, Confuciusornis had no teeth or claws on its wings, which means it couldn't use them for grasping branches or prey. Instead, it was likely fully adapted for flight. The problem is that while we know a lot about the physical features of Confuciusornis, we don't know much about how it moved through the air. That's because there are very few fossils of birds from this time period, and none of them include preserved feathers. Feathers preserve under very specific conditions, so most fossils are missing them entirely. Plus, even if they did have feathers, we wouldn't necessarily know what to do with them. For a long time, paleontologists assumed that feathers were used for display or mating rituals, kind of like a peacock's tail. But now, they think feathers might have had a completely different purpose. Recently, scientists studied the fossilized remains of a hummingbird and found that its feathers had hollow sections that made them lighter and more flexible, which allowed the bird to fly faster. And a similar adaptation might have helped Confuciusornis glide and maneuver in the sky. That discovery suggests that feathers might have originally evolved for something other than flight, such as keeping warm or attracting mates. Only later did they become useful for gliding. Then when dinosaurs came along, some of them adopted this adaptation and took to the skies in earnest. But which ones and how they did, it is still up for debate. Some scientists think birds evolved from theropod dinosaurs after they split from the lineage that led to modern birds. Others argue that theropods were too lizard-like to have given rise to birds at all. Instead, they may have descended from an early group of bird-hipped dinosaurs that looked like oversized chickens. Either way, scientists agree that birds and dinosaurs share a common ancestor, and that studying feathered dinosaurs can help us better understand our own origins. Because before birds were tweeting about the weather on Twitter, they were flapping their tiny wings and trying to figure out how to survive on a strange and ever-changing planet. Now, thanks to the discovery of fossils, we're learning more about what life was like back then and how all living things came to be. Thank you for watching this episode. If you want to learn more about birds, you can check out the playlist on our channel. Thanks to these supporters for making it possible for everyone to learn about the amazing science that surrounds us every day.